Imagine asking a brilliant philosopher to solve a complex logic puzzle, but forcing them to speak only in rigid computer code from the remarkably first word. They would likely stumble because the rigid format strangles their ability to think through the problem. This paper, titled Thinking Before Constraining, explores how to let large language models reason freely before they commit to a structured output. To understand the core problem, consider that large language models excel at free-form reasoning, yet industrial applications demand structured outputs like JSON. The authors identify a critical trade-off. When we force a model into a strict schema from the very beginning, we inadvertently cut off its ability to develop a chain of thought, leading to significantly lower accuracy on complex tasks. The researchers propose a new strategy to resolve this tension by shifting when the constraints are applied. While standard decoding locks the model into a grammar from the first token, the proposed in-writing approach allows the model to reason naturally first. It only activates the strict constraints when the model signals it is ready to write the final answer. Moving to the mechanism, this diagram illustrates specifically how the framework handles the transition. The model begins by generating free text to think through the problem, but the moment it produces a specific trigger token, like a curly brace, the system switches to a guided decoding state that masks out everything except valid schema tokens. By implementing this hybrid approach, the results are quite substantial compared to traditional methods. The authors report up to a 27% gain in accuracy on reasoning tasks, all while adding a negligible overhead of just 10 to 20 tokens compared to natural generation. Beyond raw accuracy, this method offers a major practical advantage for deployment. It proves that even small, lightweight models can function as their own robust parsers, eliminating the need for complex, two-stage pipelines where a second model is tasked just with formatting the answer. However, the researchers note that this system is not without its risks. If a model generates a trigger token like a bracket prematurely, it gets forced into the schema before it has finished thinking, and like any unconstrained generation, the reasoning phase can occasionally get stuck in a loop. In summary, this paper demonstrates that we do not have to choose between the messy intelligence of free thought and the reliability of structured data. We just need to let the model think before it types. For more insights on efficient AI architectures, visit emergentmind.com.